Good morning, class 10th. Today we are going to discuss about the properties and theorems on circles. We have already discussed one theorem in my previous lecture, which was double angle property. I would like to revise that property before I go further up. We had discussed that angles. This is a circle. This is any this any arc AB subtends an angle APB at the circumference and subtends angle AOB at the center. We had discussed that the angle subtended by an arc, suppose I take the arc AQB. The angle subtended by an arc AQB at the center is double the angle which it subtends at any point on the remaining part of the circumference. What does it mean when it says remaining part of the circumference? I've already taken the arc AQB, so I cannot take that point anywhere on AQB, but P has to be taken from this major arc, has to be taken on the major arc. So P is a point on the major arc. So the minor arc subtends an angle AOB at the center, and the minor arc subtends an angle APB at the remaining part of the circumference. The relation is that the angle at the center is double the angle at the circumference. And we have discussed this problem. We have proved this theorem in the previous lecture. Also, we had done a lot of questions on this, but just to recap the whole thing, I did this. Today, we are going to discuss about same segment. I want to make it very clear because this is very confusing for a lot of children, that what is the same segment. That is why I have drawn three figures. And I will take a lot of time in explaining it to you, that what is the same segment, because all the theorems which we are going to discuss now will be on segment. Segment is very important. First of all, we had told you also while discussing the definitions of circles, what is a segment. A chord of a circle divides the circle into two parts. Like the chord AB is dividing the circle into two parts, two areas. One is this part, one is this area, which is a smaller area, which is called minor segment. And the segment which contains the center of the circle, or the larger area, is called major segment. Now, we have to be very careful that if AB is the chord, then what happens is suppose with AB we have formed many triangles in the major segment, where the vertex of this triangle lies somewhere on the major arc. Vertex of the triangle, of all these triangles, ABL or AMB or ANB or APB are lying, these all vertices L, M, N, P are lying on the major arc. So AB has to be the same, the base has to be same, then we can say that angle ALB, angle AMB or angle ANB or angle APB are angles in the same segment. You can notice everywhere the base is AB is there, and the vertex is here somewhere, L, M, N, P. There can be many more. There can be many, infinite number of points can be there from point A coming to point B. So any number of triangles which will be formed, the angles, the vertical angles, like ALB, AMB, A and B, APB are angles in the same segment. These are angles in the same segment. For the same segment, you have to have the base same. The base must be the same for all these triangles. Now let us look into figure number 2, where I have taken the minor segment. I have drawn this chord CD below the center. So obviously this is major segment, and whatever work has been done in the minor segment. Again, in this segment, if you notice, I have formed 3 triangles with the base as CD, the base as that chord which is dividing into 2 segments. I am taking angle CED or angle CFD or angle CGD. All these angles are in the same segment. They are in the same segment. These angles are in the same segment here. These angles are in the major segment. These angles are in minor segment. Base has to be the same. Here base was AB, here base is CD. So you have to clearly understand what is the same segment. That's why I've written the topic as same segment, because next theorems what we are going to talk about is about the segment. Now let us see the third figure. In the third figure, if I join R to S, R to M, suppose, to distinguish between the chords P to Q or P to S, all angles which are framed here are in the major segment, but you will notice none of them have the same base. Like if I say triangle, if I take this angle PKQ, or if I take angle RTM, or if I take angle PLS. In all of them, maybe this, when I'm taking RM as a base, this is a major segment. But when I'm taking PQ, this is the major segment. And when I'm taking PS as the base, this is the major segment. But none of the triangles have the same base. None of the triangles have the same base. Though all of them are in major segment for every chord, but they are not angles in the same segment. I cannot say that these angles are in the same segment. They are not. We can say that angles are in the same segment only when your base or the chord is the same. The chord is here the same in this case, chord is here in the same, but here all chords are different and they are framing different angles. This seems to be the same segment, major segment, but they are not angles in the same segment. So the theorems which we are going to discuss after this is that angles in the same segment of a circle are equal. Angles in the same segment of a circle are equal. So all these angles, ALB, AMB, ANB, APB will be equal to each other. If this is X, this will be X, this will be X, this will be X. These all angles are going to be equal. Angles in the same segment of a circle are equal. This is a very important property because we are going to apply it time and again in the next theorem. Here also, if you see here the arc CD, so if I take this angle as Y, this angle as Y, and this angle as Y, then I would say that angle CED is equal to angle CFD is equal to angle CGD. Angles in the same segment, whether they are in the minor segment or major segment, but please remember the base has to be the same. Base has to be one chord only, they can't be different chord. Here they are all going to be equal, Y, here they are going to be all equal, X. But here, if you see in the third figure, these angles are not going to be equal. L, this will be something else. If it is X, it may be Y. it may be Z, they are not going to be equal because they are not angles in the same segment. So next proposition will be that the angle in the same segment of a circle are equal. Like we explained to you in the beginning that what is the same segment, because now I'm going to discuss the theorem related to the same segment. Like the statement of the theorem is, angles in the same segment of a circle are equal. That is why it is very important to understand what is same segment, and that is why we took so much of time explaining to you what the same segment is all about. Now here, if you see, look at this figure, AB is any chord, and we have two angles, angle ACB and angle ADB in the same segment. I told you the base has to be the same for the triangle. For the triangle ACB and for triangle ADB, the base is AB, so these two are same in the same segment. They are in the major segment. They are in the major segment. The given is a circle with center O, circle has got center O, ACB and ADB are angles in the same segment of the circle. What is the construction we have to do? We join O to A, we join O to A and we join O to B. We join O to A and we join O to B. We have joined the center O to the point A, one end of the chord, and O to the another end of the chord. So for all these triangles, whether it is AOB, whether it is ACB or ADB, the base is the same. The base is same. Now join A and B to O, that's what we have written. Now we are going to prove it. We are going to use the theorem which we have already learned, that angle subtended by an arc at the center of a circle is double the angle which it subtends at the remaining part of the circumference. For example, I will say, you see the first is AOB is double of angles ACB. This angle AOB is double of angle ACB. That is the first theorem we had discussed, that angle subtended by an arc at the center of the circle is double the angle which it subtends at the remaining part of the circumference. Then another part of the circumference means leave this arc AB, which is a minor arc. This point could be anywhere on the major arc. So we have picked up one point C. So angle AOB is double of angle ACD. That is what we have written here. Angle AOB is double of angle ACB. Then in the next step I write that angle AOB is also double of angle ADB. The reason we have written double angle property, angle subtended by an arc at the center is double the angle which it subtends the remaining part of the circumference. So we had told you in the beginning only that these points CD or anywhere, if you pick up a point on the remaining part of the circumference, all angles will be equal. We have just taken two angles to illustrate this point, but this point CD is not unique. They can be anywhere on major arc. So we are saying angle AOB is double of ACB, angle AOB is double of angle ADB. Now realize that double of ACB, double of ADB is the same, that is angle AOB. 2 angle ACB is equal to 2 angle ADB is equal to AOB. So 2 ACB is equal to 2 ADB, that means their halves will also be equal. When the doubles are equal, their halves have to be equal. That means angle ACB will be equal to angle ADB. The angles in the same segment of a circle are equal. I can just take to explain to you any point here. If I join this to this and if I join this to this, suppose this is E. If I take a point here, F, then all these angles will be equal. Angles in the same segment are going to be equal with the same reason. The angle at the center is double the angle which it subtends the remaining part of the circumference. So these ECDF are not unique. They can be anywhere starting from here or here and going all around in the major arc. They can be indefinite number of points on the major arc, and we can frame an angle, indefinite number of angles with their vertices on the major arc. So all those angles are going to be equal with the same logic, that angles in the same segment of a circle are equal, and basically we have used the property that angle subtended by an arc at the center of the circle is double the angle which it subtends at the remaining part of the circumference. Now we are going to do some problems after this on the same issue. Okay, now we are going to do some problems based on the theorem which we did just now. The theorem was that angles in the same segment of a circle are equal. We had proved the theorem based on that angle subtended at the center of a circle is double the angle which it subtends the remaining part of the circumference. Now let us look into problem number 1. I have a circle with center O. This arc AB is subtending angle AOB at the center, which is 100 degree. There are two other angles ACB and ADB, which are given as X and Y. I have to find out the value of X and Y. So I would say that number 1, angle ACB, or I would say angle AOB is double of angle ACB. The reason being double angle property, angle at the center or double angle property. The angle at the center is double the angle subtended by the same arc at the remaining part of the circumference. So angle AOB is double of angle ACB. AOB is how much? 100. It is double of ACB. So ACB will be how much? Will be half of 100. That will be 50 degree. So we calculated the value of X to be 50 degree. The angle subtended by an arc at the center is double the angle which it subtended the remaining part of the circumference. And X will be equal to Y. Y will be X is equal to Y. Angles in the same segment. Angles in the same segment. Angles in the same segment of a circle are equal. So angle X is 50, then angle Y is going to be 50 as well, by application of the property that angles in the same segment of a circle are equal. Now let us see question number 2. So you should be very clear. If it is 100 degree, it is going to be 50. Double angle property, angle at the center is double the angle at the circumference subtended by the same arc. This arc is here minor arc. Minor arc, let me name it something, APB. The minor arc APB subtends angle AOB at the center, and the same arc APB subtends angle ACB at the remaining part of the circumference. C is on the remaining part of the circumference. Leave the portion APB, and C should be picked up somewhere here. So the relationship is that X will be half of 100, or this AOB will be double of ACB, and X will be equal to Y. Why? Because angles in the same segment of a circle are equal. Now let us see question number 2. In question number 2, we have a circle with center O. The arc PQ is subtending an angle POQ at the center, and the same arc PQ is subtending angle PRQ at the circumference and also PSQ at the circumference. I know what is the value of angle PSQ. It is given to be 60 degree. So we have to calculate first of all POQ. We can calculate first X or first Y, it doesn't matter. I can say X is equal to 60 degree. Why? Angles in the same segment. They are angles in the same segment. Angles in the same segment. Angles in the same segment of a circle are equal. So angle PRS is equal to angle PS, PRQ, not S, PRQ. Angle PRQ is the same as PSQ, will be equal to 60 degree. That is what we have written. X is equal to 60 degree. Angles in the same segment of a circle are equal. And the next property is that angle POQ will be double of angle PSQ. Angle, it's double angle property. Double angle property. What is the double angle property? That angle subtended by an arc at the center of the circle is double the angle which it subtends at any other part and on any part remaining part of the circumference. POQ is Y. It will be double of PSQ, which is 60 degree. So Y will be 120 degree and X is 60 degree. So this is your, we are using two properties, double angle property and the property that angles in the same segment of the circle are equal. This was question number 2. Now we will look into question number 3 and I'll have to rub out this. Question number 3. Now please see AB, if I take it APB is the major arc. It is a major arc because it contains, it is center of the circle. Now the arc, the chord AB divides the circle into two segments, major segment and the minor segment. These two angles ACD, ACB and ADB are formed in the minor segment. But the relation does not change. Angles in the same segment of a circle are equal. Instead of major segment, they are in minor segment. This reflex angle AOB is given 220. I have to calculate the value of ACB and ADB. I know ACB and ADB will be equal. So if I could calculate the value of angle ACB, angle AOB, reflex angle AOB, reflex angle AOB is double of angle ACB, that is double of whatever the angle is here. Suppose, let me name it X, I have to be Y, double of X, and reflex angle is how much? 220 degree. So X will be equal to 220 upon 2, that is 110 degree. Double angle property. It is again double angle property. Angle subtended at the center by an arc is double the angle which it subtends the remaining part of the circumference. This arc, major arc, this is major arc. This major arc is subtending the reflex angle AOB in the center, and this major arc is subtending angle ACB and angle ADB at the remaining part of the circumference. So, relation is that the angle at the center is double the angle at the circumference. Also, this was first. Second will be that x is equal to y will be equal to 110-degree same segment property. Angles in the same segment of a circle are equal. Angles in the same segment of a circle are equal. So based on the two theorems which we have done, we have discussed these three problems. Earlier also we have done problems. Now we'll shift to the next theorem. The next theorem in this series is that the angle in a semicircle is a right angle. Angle in a semicircle is a right angle. Like, look at this figure here. AB is the diameter, AOB is the diameter, O is the center of the circle. Diameter is, again, we told you, is the biggest chord of the circle. Diameter is the biggest chord of the circle. And diameter divides the circle into two equal halves. Each half will be, we can call it a segment. We call it semicircles actually. So this segment AOBP is a semicircle. ACBO is also a semicircle. What we have to prove is that the angle in a semicircle is a right angle. I have picked up this semicircle, top one. You can pick up the lower one also, there is no problem. Angle will be right angle only. What we have to prove is that angle ACB is 90 degree. Wherever, again, C is not unique. C could be anywhere. It could be here, it could be here, it could be here, it could be here, it could be here. The position of the point C is not unique. A and B are unique. A and B have to be end of the diameter. Now here what he has given is that a circle with center O, AOB is the diameter. We have to prove, we are required to prove that this angle ACB will be 90 degree. I have to prove the angle ACB is 90 degree. Now the method of proving is that we are saying that this angle AOB is how much? It is 180 degree. A straight line is of 180 degree. And this angle is subtended by the arc APB at the center. This arc APB subtends angle AOB at the center. The arc APB subtends angle AOB at the center. And the same arc APB subtends angle ACB at the remaining part of the circumference. That means you leave this half of the circumference and C is on the another half. So the relationship will be the same. The angle subtended by an arc at the center of the circle is double the angle which the same arc subtends the remaining part of the circumference. So angle AOB will be double of angle ACB. Angle AOB is 180 degree. So ACB will be how much? ACB will be half of 180 degree. So ACB, angle ACB will be 90 degree. Angle in a semicircle is always a right angle. Angle in a semicircle is always a right angle. We are going to do problems based on the theorem which we have just done, that angle in a semicircle is right angle. But that is not the only theorem which we are going to use while solving these problems. We will be also using the theorems which we have already studied, that angle subtended by an arc at the center of the circle is double the angle which it subtends at the remaining part of the circumference. Also, angle in the same segment of a circle are equal. And the third theorem which we have studied is that angle in a semicircle is right angle. So all these three theorems we are going to use when we are going to solve the problems on circles. Like in this first problem, I have a circle with center O. AB is the arc which subtend angle AOB at the center. COB is the diameter. What I have to find is, I have to find angle ACB, I have to find angle OAC, and also I have to find angle OAB. Now let us look. This arc AB subtends angle AOB at the center, and the same arc is subtending angle ACB at the remaining part of the circumference. So angle AOB is double of angle ACB. Angle AOB is double of angle ACB. Angle subtended at the center is double the angle which it subtends the remaining part of the circumference. It is also double angle property. Double angle. Every time writing the whole statement which I am speaking, I'll say double angle property. Angle subtended by an arc at the center of the circle is double the angle at which subtends the remaining part of the circumference. So angle AOB is how much? 70 degree. It is double of angle ACB. Or ACB will be how much? Angle ACB will be obviously half of 70, that is 35 degree. We get this angle ACB as 35 degree. We get the angle ACB as 35 degree. Now he says find angle OAC. I would say angle OAC is equal to angle OCA is equal to 35 degree, as OA is equal to OC, radii of the same circle. Radii of the same circle. In triangle OAC, OC is equal to OA because they are radii of the same circle. And if the two sides of a triangle are equal, then angles opposite to them are equal. So OAC will be equal to OCA is equal to 35. Now I would say angle CAB is 90 degree. CAB is 90 degree. Why? Angle in a semicircle. COB is the diameter. So the diameter divides the circle into two equal halves, and each half is called a semicircle. So this angle CAB is angle in a semicircle. Angle in a semicircle. Angle in a semicircle is right angle. Angle in a semicircle is right angle. Angle in a semicircle is right angle. So this complete angle CAB is 90, but this portion is how much? 35. So I can take out OAB is the faulting angle OAB. Angle OAB will be 90 minus 35. That will come out to be 55 degree. That will come out to be 55 degrees. So I've got all the three angles. I calculated angle ACB by applying the theorem that angle subtended by an arc at the center of the circle is double the angle which it subtends the remaining part of the circle. So I got ACB as a half of 70. Then I said angle OAC and angle OCA will be equal because two sides of the triangle are equal. So angles opposite to them will be equal. So I got angle OAC as 35 degree. Once I've got it 35, I said angle CAB is 90 degree. Angle in a semicircle. And once I've got this angle is 35 and this whole angle is 90 degree. So from 90 I subtracted 35 to get the angle OAB, which is 90 minus 35 will be equal to 55 degree. So we've got all the three angles what he required, and we must write the reason like we wrote double angle property, or as OA is equal to OC radii, or angle in a semicircle. We must write the reasons. Let us look into this question number 2. In question number 2, again I have AOB as the diameter. If AOB is diameter, that means I will be using somewhere the property of the semicircle. If AOB is diameter, then angle APB will be 90 degree. First thing will be angle APB will be 90 degree. Angle in a semicircle. Angle in a semicircle. Angle in a semicircle is right angle. Angle in a semicircle is right angle. Because AOB is the diameter, AOB is the diameter, so diameter will divide the whole circle into two equal halves. So angle APB is angle in a semicircle. Please do not confuse the angle PCB. PCB is not the angle in a semicircle. Why? Because PB is not the diameter. So this angle comes out to be 90 degree. This angle comes out to be 90 degree. APB is 90 degree. This angle is given as 45 degree. So I can calculate angle PAB. I can calculate angle PAB. How much will be angle PAB? PAB will be 180 minus 90 plus 45. Sum of the angles of a triangle, sum of interior angles of a triangle is always 180 degree. Sum of interior angles of a triangle is always 180 degree. Two angles are known, 90 and 45. So for calculating the third angle, what I do is subtract the sum of 90 and 45, sum of 90 and 45 from 180 degree. 180 minus 90 is 90, 90 minus 45 is 45. Now this angle comes out to be 45. Now I have to find angle D, this angle PCB. I would say angle PCB will be equal to angle PAB. PAB will be equal to 45. Same segment. Angles in the same segment of a circle are equal. And we must see what is the same segment. This is the chord. This is the chord. Chord PB. Chord PB is making in this segment angle PAB and PCB. And both these angles PAB and PCB will be equal, and since it is 45, this angle will also be 45. I had to calculate angle D, so I have used two theorems in this actually. First theorem I used angle in a semicircle, which is right angle, because AOB was diameter. Then I used the second theorem, the sum of angles of a triangle, sum of interior angles of a triangle is 180 degree, which is the theorem, which is one of the basic theorem which you've learned in junior classes. So this was 90, this was 45. We added 90 plus 45, it became 135. You subtracted out of 180, you got it has to be 45. Once I got this 45, I said angle PAB will be equal to angle PCD, angles in the same segment of a circle. Angles in the same segment of a circle are equal. So PCB is equal to PAB is equal to 45, same segment property. Angles in the same segment of a circle are equal. This is the second problem we have discussed. Now let us look into the third problem, which is a figure drawn here. Again, POR is the diameter. POR is diameter, and diameter is dividing the circle into two equal halves. Each half is called a semicircle. And if you realize that here in this semicircle, PQR is an angle, so obviously this is going to be 90 degree. And PSR will be also 90 degree, because this is the angle in the other semicircle. But he is not talking of finding angles here. He is asking you to calculate perimeter of the figure PQRS, where he has given PR as the diameter. PR is the diameter. So when I have two right angle triangles, I can apply Pythagoras theorem. And what is Pythagoras theorem? In a right angle triangle, the square described on hypotenuse is equal to the sum of the squares described on the remaining two sides. In the triangle PQR, I will say angle PQR is 90 degree. Angle in a semicircle. So this triangle becomes a right angle triangle. PQR is a right angle triangle. And the side opposite to 90 degrees hypotenuse. So I must find hypotenuse, that is PR whole square will be equal to PQ square plus QR square. Pythagoras theorem. Pythagoras theorem states this square described on the hypotenuse is equal to the sum of the square described in the remaining two sides. So it will become 7 square plus 6 square, 49 plus 36. It will come out to be 85. I'm not going to calculate the square root of PR because I am not asked to calculate PR. What he is asking me to calculate is actually I have to find PS. I have to find PS because already I know three sides. This is 7, this is 6, and this is 2. If I could find this, then I can find the perimeter of the figure PQRS. Now in triangle PSR, let us calculate. Again apply Pythagoras. PR square will be equal to PS square plus SR square. Now PR square I have already calculated. This is why I did not take out the square root, which is 85. It is 85. PS I have to calculate, and this is how much? 2 square. Because the value of SR is 2. So 2 square is 4. So it will become 85 minus 4 will be equal to PS square. PS square becomes 85 minus 4. So PS square will become 81, which is 9 square. So PS will be 9. I'm not writing plus minus because length is always going to be in plus. It should be actually modulus of, whenever we take the square root, we should write modulus because here we are talking about the length. So PS is 9 centimeter. PS is 9 centimeter. So what will be the perimeter? Now you've got all the four sides. What is the perimeter? Perimeter is the sum of all the sides. 7 plus 6 plus 2 plus 9. 7, 6, 13. 13 plus 2, 15. 15 plus 9, 24. 24 centimeter. So he did not ask you to calculate any angles in this particular problem. He asked you to calculate the perimeter of this figure, and where he had given that POR was diameter, so POR was dividing the circle into two equal halves, two semicircles, and in each semicircle we could say that angle Q and angle S is 90 degree, and if angle Q and angle S are 90 degree, then these two triangles are right angle triangle. And when the triangles are right angle triangle, we can apply the property of Pythagoras theorem. And what is Pythagoras theorem? In a right angle triangle, the square described on the hypotenuse is equal to the sum of the squares described on the remaining two sides. By applying Pythagoras theorem to triangle PQR, I calculated PR square to be 85. PR square to be 85. Then I applied the Pythagoras theorem to triangle PSR because it was given 2. I have already PR and I have to calculate PS. So we applied the Pythagoras theorem and we calculated the length PS to be 9 centimeter. Once we've got all the 4 sides of the quadrilateral, then we are going to we will add the sides because perimeter is sum of the bounded figure, sum of the sides of a bounded figure. 7 centimeter plus 6 centimeter plus 2 centimeter plus 9 centimeter, which comes out to be 24 centimeter. Okay. Next theorem in this series is about cyclic quadrilateral. What is a cyclic quadrilateral? You know what a quadrilateral is. A figure bounded by 4 straight lines is called a quadrilateral. When we attach the word cyclic to it, in a circle, if a quadrilateral is drawn so that its vertices are lying on the circumference of the circle, or a quadrilateral inscribed in a circle is called a cyclic quadrilateral. For example, this figure ABCD is a quadrilateral and the vertices A, B, C and D are lying on the circumference of the circle, then it is called a cyclic quadrilateral. And a cyclic quadrilateral will always follow certain properties like every geometrical figure does. Now, what we have to prove according to this theorem is that the opposite angles of a cyclic quadrilateral are supplementary. Opposite angles. This angle A and angle C are opposite angles. Angle B and angle D are opposite angles in this cyclic quadrilateral. Now he says, given as a circle with center O, a circle with center O, and ABCD is cyclic quadrilateral. What are we required to prove? That angle BAD plus angle BCD is 180 degree. If the sum of two angles is 180 degree, they are called supplementary angles. Similarly, angle ABC plus angle ADC is equal to 180 degree. I am going to prove the first one, second will obviously follow according to that. The construction is we have joined O to B and O to D. Now let us look that how are we going to prove it. We are going to say that this angle BOD is subtended by the arc BCD. BOD is the angle subtended at the center by the arc BCD. And the same arc BCD subtends angle BAD at the remaining part of the circumference. So the relation is that angle at the center is double the angle subtended by the same arc at the remaining part of the circumference. So we are saying angle BOD is double of angle BAD. So if I have assumed the angle BAD to be x, then this angle is going to be 2x. Similarly, we will say reflex angle BOD. This reflex angle BOD is subtended by the arc BAD. This arc BAD subtends reflex angle BOD at the center. This is major arc. Major arc subtends always a reflex angle at the center. And this major arc subtends angle BCD at the remaining part of the circumference. Relation is the same. That angle at the center is double the angle which it subtends at the remaining part of the circumference. So reflex angle BOD is equal to double of angle BCD. Again, we have written the reason as double angle property. Now, if I add these two results, angle BOD plus reflex angle BOD will be equal to double of BAD plus double of BCD. BOD plus reflex of BOD, if I add this BOD plus reflex of BOD, how much will I get? 360, because angles around a point, the sum of angles around a point is 360 degree. So BOD plus reflexive angle BOD is 360 degree. Out of this I can take 2 common, so it will be left angle BAD plus angle BCD. So what will be the sum of angle BAD plus BCD? 360 by 2, that is 180 degree. And BAD and BCD are opposite angles of cyclic quadrilateral, and we had to prove BAD plus BCD is equal to 180 degree. In similar fashion, I can join O to A and O to C, and we can prove that angle B plus angle D will be 180 degree. This sum of angle B plus angle D will be 180 degrees. So the opposite angles of a cyclic quadrilateral are supplementary. Once again, what is a cyclic quadrilateral? It is a quadrilateral inscribed in a circle. When we say inscribed in a circle, that means the vertices of this quadrilateral will be lying on the circumference of the circle, like we have shown in this figure. It is a very important property. We will be doing a lot of practical problems based on these. First theorem was that angle subtended by an arc at the center of the circle is double the angle which it subtends at the remaining part of the circumference. Second theorem, what we did was angles in the same segment of a circle are equal. The third theorem we did was angle in a semicircle is right angle. And this is the fourth theorem where we have proved that the opposite angles of cyclic quadrilateral are supplementary. We are going to discuss some problems based on cyclic quadrilateral. There are 3 questions which we are going to discuss based on cyclic quadrilaterals. Now let us look into question number 1, where A, B, C, D is a cyclic quadrilateral. O is the center of the circle. Angle BOD is given as 130 degree. He wants to find out the value of angle A and angle B. So this arc BCD, or actually arc BAD. Arc BAD subtends angle BOD at the center, and the arc BAD subtends angle BCD at the circumference. So angle BOD is double the angle BCD. Double angle property. Double angle property. The angle subtended by an arc at the center of the circle is double the angle which it subtends at the remaining part of the circumference, subtended by the same arc. The arc is BAD. The arc is BAD. The arc BAD subtends angle BOD at the center. This is a minor arc. This is a minor arc. Minor arc subtends angle BOD at the center, and the minor arc subtends angle BCD on the remaining part of the circumference, which is major arc. C is on the major arc. So relation is that this angle BOD will be double of angle BCD. And angle BOD is 130 degree. It is double of B, because this angle is given B, or B will be equal to 130 upon 2, that is 65 degree. We got the value of B as 65 degree. By the application of the property that angle subtended by an arc at the center of the circle is double the angle which it subtends at the remaining part of the circumference. And second one is angle A plus angle B. A plus B will be 180 degree. Why? Because ABCD is cyclic. The opposite angles of cyclic quadrilateral are supplementary. The opposite angles of cyclic quadrilateral are supplementary. I already have the value of B, which is 65. So A plus 65 will be 180 degree. So A will be equal to 180 degree minus 65 degree, that will be 115 degree. The opposite angles of cyclic quadrilateral are supplementary. The two properties which we have applied are double angle property. Angle subtended by an arc at the center of the circle is double the angle which it subtends at the remaining part of the circumference, and the opposite sum of the opposite angles of cyclic quadrilateral are supplementary, from which we got the value of A as 115. So we have got B as 65 and we have got A as 115. Both the answers are there. Now let us look into question number 2 here. In second question also, ABCD is a cyclic quadrilateral because this quadrilateral is inscribed in a circle. And the another thing which is attached to this is that he has given you DC parallel to AB. So this figure actually is a trapezium, a quadrilateral. It's a cyclic trapezium actually. It's a cyclic trapezium because AB is parallel to CD. AB and CD are parallel and obviously they are not equal in length, which I can see. So it is a cyclic quadrilateral. You can call it a cyclic quadrilateral. We will apply the properties of cyclic quadrilateral plus the property of parallel lines. I can simply find angle C first of all. I would say number 1, that angle BCD plus angle BAB will be 180 degree. Why? ABCD is cyclic. Opposite angles of cyclic quadrilateral are supplementary. This A and C are opposite angles. I know what is the value of BCD plus 105 is equal to 180. So I can calculate angle BCD as 180 minus 105. That will be how much? 75 degree. We have got this value as 75 degree by the application of the property of cyclic quadrilateral. The opposite angles of cyclic quadrilateral are supplementary. Now, let us apply the property of parallel lines, because for finding out these two angles, I'll have to apply the property of parallel lines. And what is the property of parallel lines? If two lines are parallel and third line cuts it, then co-interior angles are supplementary. Because this angle and this angle plus this angle will be 180 degree. This and this is parallel and it cuts it. This line is parallel to this and this line cuts it. These becomes co-interior angle. So I would say angle BAD plus angle ADC will be 180 degree. Why would be this so? Because AB is parallel to DC. AB is parallel to CD, co-interior angles. These are called co-interior angles. Co-interior angles are always supplementary when lines are parallel. So BAD I know is 105 and this is ADC will be 180 degree. So angle ADC will be 180 minus 105, that will be 75 degree. I have got BCD as 75, I have got ADC as 75. Now I have to calculate, this also is 75, I have to calculate this angle. ABC, angle ABC plus angle ADC will be also 180 degree, because opposite angles of cyclic coordinate are supplementary. ABCD is cyclic, coordinate. When I write cyclic, that means it's a cyclic quadrilateral. So out of this ADC I know 75. So angle ABC will be how much? 180 minus 75, that will be 105 degree. This will come out to be 105 degree. This is 105 degree. So you can see that we have got all the four angles of the cyclic quadrilateral. Now if you look in the next figure, question number 3, then I have AOB is the diameter. So maybe we will have to apply somewhere the property of the semicircle. And ABCD is a cyclic quadrilateral. A is joined to C. This angle is given 130. He wants us to find BAC. He wants to find angle BAC. Of course, I will apply first property. ADC is 130. I can calculate this angle by saying opposite angles of cyclic quadrilateral are supplementary. I would say that angle ABC plus angle ABC is equal to 180 degree. ABCD cyclic is, it is a cyclic quadrilateral. It is a cyclic quadrilateral, so opposite angles of cyclic quadrilateral are supplementary. So I will calculate angle ABC to be 180 minus 130 degree, so it will come out to be 50 degree. This has come out to be 50 degree by the application of cyclic angle property, cyclic quadrilateral property. Then I would say that angle ACB will be 90 degree. Why? This is a semicircle, angle in a semicircle property. What is semicircle property? The angle in a semicircle is always a right angle. AOB is the diameter and this is angle in a semicircle. This will be 90 degree. So now what will be the value of angle BAC? Third one, angle BAC will be 180 minus 90 plus 50. It will come out to be 40 degree. It will come out to be 40 degree because the sum of the angles of a triangle is 180 degrees. So it will come out to be 40 degree. So we have applied, if you look from one to the last, we have applied all the theorems which we have studied. We have studied the angle subtended by an arc at the center of a circle is double the arc which it subtend at the remaining part of the circumference. We have applied the property, the opposite angles of cyclic quadrilateral are supplementary. We have applied the property of parallel lines which you have studied in junior classes. If two parallel lines are there and a third line cuts, then the co-interior angles are supplementary. We have applied the property of semicircle, angle in a semicircle is right angle. We have applied the property that sum of the interior angles of a triangle is 180 degree. In this theorem, the statement is the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. What does it mean? Like if you look at this figure, ABCD is a cyclic quadrilateral. That means a quadrilateral is inscribed in a circle. A, B, C and D are on the circumference of the circle. Any one of the sides of the quadrilateral is extended. Like here, I have extended the side AB to a point D. Then according to this theorem, what he is saying is that the exterior angle, what is the exterior angle? CBE. The exterior angle of this cyclic quadrilateral is CBE. It will be equal to the interior opposite angle. The opposite is this angle AC, ADC, angle ADC. So it is given as a circle with center O, ABCD is cyclic, quadrilateral, AB is extended, angle CBE is exterior angle. Now what we have to prove is that angle CBE, the exterior angle, is equal to the interior opposite angle, that is angle ADC. For the proof part, what we are going to do, we are going to say in quadrilateral ABCD, which is a cyclic quadrilateral, the opposite angles of cyclic quadrilateral will be supplementary. Angle ADC plus angle ABC will be equal to 180 degree. Similarly, this plus this will be also 180 degree. The opposite angles of cyclic quadrilateral are supplementary. So ADC plus ABC is equal to 180 degree. The other thing is that I would say that angle angle ABC plus angle CBE will be also 180 degree. Angle ABC plus angle CBE is equal to 180 degree. Why? Because ABE is a straight line, and a straight line is always of 180 degree. Two adjacent angles formed on the two sides of a straight line are supplementary. So they are also 180 degree. Now if sum of this angle is 180 and sum of these angles is equal to 180, that means they should be equal to each other as well. So angle ADC plus angle ABC will be equal to angle ABC plus angle CBA will be equal to 180 degree. So this and this will cancel. So that means remaining is ADC will be equal to CBE. The exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. Okay, we will continue solving problems based on whatever we have studied in circle till now. As I said, I'll recap the whole thing again. First theorem which we studied was that angle subtended by an arc at the center of circle is double the angle which it subtends at the remaining part of the circumference. Second theorem we had studied that angles in the same segment of a circle are equal. Third theorem we had studied that angle in a semicircle is right angle. Angle in a semicircle is right angle. Fourth, we had studied that opposite angles of cyclic quadrilateral are supplementary. And the next theorem we had studied that if one side of the cyclic quadrilateral is extended, then the exterior angle is equal to the sum of the opposite interior angle. Based on these theorems, we are solving out, we have already solved some problems for you. I'll continue doing more problems based on these. Like I have two problems drawn on the board just now. On the extreme left of the board, I have a circle in which center is O. This PR is not diameter because it is not passing through O. PR is just a chord, and PQR is a triangle drawn here in which PQ is equal to QR. PQ and QR are equal. Angle QPR is given to be 40 degree, and he has extended the side RS to a point E, so that we have got this exterior angle formed of the cyclic quadrilateral. I have to find this angle PSE only in this. So the first thing what I will say is that in triangle PQR, I will say that angle QPR is equal to angle QRP, which will be how much? 40 degree. Why will it be 40 degree? Because if two sides of a triangle are equal, then the angles opposite to them are equal. The reason is PQ is equal to QR. Now I have got this is 40 degree. So I can calculate the third angle of the triangle, that is angle PQR. So angle PQR will be 180 minus 14 plus 40, because I know two angles of the triangle, so I can calculate the third angle of the triangle by subtracting it out of 180, which will come out to be 100, because 180 minus 80 will give you 100 degrees. So this angle comes out to be 100 degrees. I have to find angle PSE. I have to find angle PSE. So angle PSE will be equal to angle PQR, will be equal to 100, because exterior angle of a cyclic quadrilateral is equal to interior opposite angle. The exterior angle of cyclic quadrilateral, this is an exterior angle of the cyclic quadrilateral. This quadrilateral will be equal to the opposite interior angle. You could have simply, you can understand this way also, if it is 100, it will be 80. Because this PQRS is a cyclic quadrilateral. If it is 100, it will be 80. Why? The opposite angles of cyclic quadrilateral are supplementary. So if it is 100, it will be 80. So it will be how much? 180 minus 80. This is one way of saying it. But instead of applying this, I applied directly that the exterior angle of cyclic quadrilateral will be equal to the opposite interior angle. So we got the value of PSE which we wanted to calculate. Now let us see this second problem. Let us see problem number 2. In this also, ABDC is a cyclic quadrilateral. ABDC is a cyclic quadrilateral because the only thing which is given is that AB is the diameter. AB is the diameter. So maybe I use somewhere the diameter property if required. I don't know. We'll have to solve the problem and see it. AB is extended to point E and CD is extended, and extended CD and AB meet at point E. He has given you the angle AOD is 130 degree. Angle AOD is 130 degree, and CAB is 60 degree. This is 60 degree. He wants you to calculate the angle EDB. He wants you to calculate this angle. He wants you to calculate this angle, number 1. And he wants you to calculate DBO. He wants you to calculate DBO. So this, if you look at the cyclic quadrilateral ABDC, then side CD has been extended. So I have got BDC as the exterior angle. I have got this to be an exterior angle. So the exterior angle of the cyclic quadrilateral will be equal to the opposite interior angle. So I would say that angle EDB will be equal to angle CAB. CAB will be equal to 60 degree. The exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. If it is 60, it is going to be 60. Now I want angle DBO. DBO, I want this angle. How do I calculate this angle? This is 180 degree. This angle is it is 130 degree. I can calculate this angle. I will say angle DOB will be 180 minus 130. Adjacent angles on a straight line. It will be 50 degree. Why? Because AOB is a straight line. AOB is a straight line. And here the exterior angle of a cyclic quadrilateral. of a cyclic quadrilateral. Now I have got this angle as 50 degrees. In the triangle ODB, angle ODB will be equal to angle OBD, will be equal to 180 minus 50 upon 2. Why it is so? Why are they equal? They are equal because OB is equal to OD, radii of the same circle. OB is equal to OD, radii of the same circle. 180 minus 50 is 130 upon 2. That means it is 65 degree each. This angle will be 65, so will be this 65. This will be 65, this will be 65. 65 plus 65, 130, 130 plus 50 is 180. So I wanted to calculate ODB, I want to calculate BDE. So we have got both the angles. Let's see in this problem, we have a circle with AC as diameter, O is the center of the circle. There is another circle drawn with AO as diameter. That means this smaller circle's diameter is equal to the radius of the bigger circle. There is a chord AE which is the chord of a bigger circle. And this chord cuts this smaller circle at point B. We got to prove that AB is equal to BE. We got to prove AB is equal to BE. Now, if I join B to O and I join C to E, if you look in this figure, this angle will be 90 degree. Why? Angle ABO will be 90 degree. Angle in a semicircle. Angle in a semicircle. Why it is semicircle? Because AO is the diameter for the bigger circle. So obviously the diameter will bisect the circle into two equal halves, and each half is a semicircle. So this is the semicircle. This is the semicircle of this diameter. So angle in a semicircle is right angle. ABO is 90 degree. Similarly, angle AEC will be how much? 90 degree. Because AC is the diameter for bigger circle and this is angle in a semicircle. So this angle will be 90 degree. Angle in a semicircle. In a semicircle. Now this is 90 degree, this is 90 degree, and they are perpendiculars to the same line. They are perpendicular to AE, to the same line. That means BO is parallel to EC. So BO is parallel to EC. We have read a property that if a line is drawn in this triangle, for example, AEC, I've drawn BO parallel to EC. Then this line BO will divide both the lines in the same ratio. So BO is parallel to EC in triangle AEC. AB upon BE, AB upon BE will be equal to AO upon OC. If you remember, this is Thales theorem or basic proportionality theorem. A line drawn parallel to one side of the triangle divides the remaining two sides in the same ratio. Whatever is the ratio, this line is drawn parallel to this, so it will divide in the same ratio. Whatever is the ratio of AB is to BE will be the ratio of AO is to OC. But O is the center of the O is the center of diameter AC. That means AO and OC are equal. That means in place of OC I can write AO, or to simplify for you, I can denote it by x by x. So it is x by x. So this will cancel each other. That will give you 1. So AB upon BE is equal to 1, or AB is equal to BE. If you cross multiply, you will get AB equal to BE, because AB upon BE is equal to 1. So when we cross multiply, we will get AB is equal to BE. So this is the thing that you have to prove, that AB is equal to BE. We have used Thales theorem here, which says that a line drawn parallel to one side of the triangle divides the remaining two sides in the same ratio. This is the solution to this problem. Now let us look into the second problem, in which O is the center of the circle. This figure is there, OCBA is the figure. This angle is A, this angle is A. Angle COA is A, angle CBA is B. He wants you to find a relation between A and B. He wants you to find a relation between A and B, number 1. Number 2, he wants you to find out the value of O. What does he say? Find OAB. Find OAB if this becomes a parallelogram. If this becomes a parallelogram. In the first case, he is not talking of the parallelogram. In the first case, he wants to find out the relation between A and B. So what am I going to do? Look here. This arc, the major arc, suppose I name it CP, arc CPA subtends angle, reflex angle COA at the center. This is reflex angle at the center. And the same arc subtends angle CBA at the remaining part of the circumference. So what is the relation? This angle should be double. It should be 2B. It should be 2B. If it is B, it should be double of that. So B, if it is B, it should be 2B. We should write it here. Reflex angle AOB is double of angle CB. Sorry, reflex angle COA. CO or AOC. Reflex angle AOC should be double of angle ABC or CBA. CBA, which is 2A. Sorry, 2B. It should be 2B. If it is B, it should be 2B. Now, angle AOC plus reflex angle AOC should be equal to 360 degree, because sum of angles around a point. This was double angle property. That was double angle property. And this is sum of angles around a point. Sum of angles around a point. AOC plus reflex angle AOC will be 360 degree. Reflex angle AOC will be double of CBA, so it is 2B. AOC is given as A. It is given as 2B. So the relation between A and B is that A plus 2B is equal to 360 degree. A plus 2B will be 360 degree. That is the relation between A and B. Now he says if OABC is parallelogram, is a parallelogram. What is the property of parallelogram? The opposite angles of a parallelogram are always equal. The opposite angles of a parallelogram are always equal. So this angle A will be equal to angle B. Opposite angles of a parallelogram. Opposite angles of a parallelogram are always equal. The opposite angles of a parallelogram are always equal. So A is equal to B. And A plus 2B we had calculated as 360 degree. So if in place of A, if I write B, so what will happen? A plus 2B was 360 degree. A plus 2B was 360 degree. So in place of A, I write B. B plus 2B is how much? 360 degree. So that will imply B will be 360 upon 3. That will be 120 degree. It will be 120 degree. If B is 120 degree, opposite angles of parallelogram are equal. So A will be equal to B will be equal to 120 degree. These angles will become 120 degree. But since it is a parallelogram, so this angle will be equal to this angle. If it is x, this will be also x. When in the second case, when it is becoming a parallelogram. So x plus how much? The sum of A plus B was how much? This was 120, 120 to 40 is equal to 360 degree. So 2x will be equal to 360 minus 240, that is 120 degree. So x will be 120 upon 260 degree. You could have used the property otherwise also. If this is 120, this will be 60. The co-interior angles are supplementary. Similarly, this is 120, this should be 60. The property of co-interior angles, because this line will be parallel to this line will be parallel to this line. As in second case, he says the figure OABC, if it becomes a parallelogram, what is the value of this angle? So using that property of parallelogram, the opposite angles of parallelogram are equal and co-interior angles are supplementary.